everyone, welcome back to my YouTube channel. Okay, so a few days ago I uploaded part 3.1 of this custom compressor beast project. If you haven't seen the 3 previous parts yet, do get a look. They are quite interesting and heavily detailed. As discussed in the previous video, these videos will follow lightning fast from here in, as I had to split part 3 into smaller sections. So just to clarify, part 3.1 focused on the selection and the mounting of the motors, the pumps, whilst finding the correct pulley sizing for optimum performance. I also routed the main lines from the pump's aftercoolers to the vessel's check valves using industrial grade pipe and fittings. Near the end of that video, I also demonstrated the system in which the custom compressor build will be fed into. In this part, I focus on the attachment of all the accessories whilst sealing all the joints, the threads, including the new feed pipes, the new fittings that I have just discussed. I also run other important pneumatic drain pipes to get the system to work as it should. When this is all complete, I will focus on the electrical side of things. So I'm not going to waste any more time here. I will start where I left off in part 3.1. So I have a lot of work to cover, so let's get started. Okay, so I'm going to remove both motors to allow better access to the mount points of the pump, but also for the tightening of these pipes, these fittings. So here we go. Okay, so we're going to start off here by placing these new bolts into the feet of the pump. Now the washers and the nuts. Okay, so the nuts are sweetened up on the bolts. So what I need to do here now is square the pump up to the vessel. So obviously, no matter how tight the holes are drilled to match the feet of the pump, there's always going to be a wee bit of play there. The holes in the pump might be a wee bit bigger than 10 mil. Another reason here, even though this bolt is 10 mil, it measures a little bit smaller because there's no shank on the bolt. Hopefully that makes sense. So what I'm going to do here is square the pump up to this platform using the square. So basically bringing the square up to the 2 feet. So I can see now that this pump needs to go this way slightly. Okay, so that looks good. So now you're just tightening the 4 nuts. Okay, on the 2 at the back. So I'll move the camera around here. So same process, same tightening sequence to the other pump needs to be completed still. So I'll do that off camera here now. And I'll move on to the sealing of all these fittings. Whew. Okay, so I have this positioned uphill for a reason. We will demonstrate that at the end when the compressor is running. New valve, the other one was done. So the handle was quite weak on the valve itself. There we go. So this time I have the handle to the side. So this 1/2 inch fitting now will be facing uphill. So I can connect my compressor to the system in the garage. Okay, so here's the old valve that I just removed. So the new valve is a 304 grade stainless steel. I don't know what happened this one. It's a white brass. I might have stood on the handle when it was lying on the ground. But that's changed now anyway, so good job. Okay, so these pipes are now complete. These pipes leading from the pumps to the vessel. So that's on both sides. So I mentioned earlier, I briefly touched on how we don't want tension at this point. So if I slacken these bolts now on both pumps, both aftercoolers, there should be no gap between the aftercooler flange and the head of the pump. So there we go. So keeping in mind, there's an O-ring sitting in a recess on the head of the pump here. So if I move this now side to side, you can see how well it lines up. If I pull it back here, gently. So I should point out, this union is now locked in position. So this is important that this lines up as good as it does, because when this pump is operational, or when it's in operation, when it's running, we don't want vibrations to occur at this point. It's okay if everything lines up, but let's say that these two mating surfaces were sitting off, so say I pulled them in with the bolts, this would, at this point of the aftercooler, or even any point off the aftercooler, let's say around this flange, it could crack. So that's especially when the heat goes into it, when things start moving about. So that's the reason I have these lining up as well as they do. So we'll just slacken the other one too. First things first, if I go down here at this point and pull this aftercooler back, the gap should be even. So what do we see? There we go. If I look through there, you can see a bit of stainless on the wall. And that should also be the same looking down on it. So it's good. So this can be tweeted still, but for the meantime, it's looking good. So we'll go over here now to this pump. Okay, do the same thing again. So there's no tension. If I was to move the pump out of the way, this aftercooler would sit in that position. So really, really good. So if we look down on it here, again, the same thing. It's perfect. So I'm not going to lie, this was quite tricky to get right. So the bend in this pipe, the position these pipes is screwed on to this bend is important, as is where this union sits on these threads. So quite a tricky process. Usually this will be done in copper, but as I say, I wanted to go bigger and keep everything more industrial spec or industrial grade. So I'm going to move on here now and start running the 6mm luminous orange lines to these check valves, which will be teed in to this pressure switch. So when the pump gets up to pressure, when it gets up to say 150 psi, this pressure switch will basically blow off these two lines. So it will drain these two lines for the next time the compressor, when it's starting up. So that's just to keep the load off the motor, so the motor is capable of starting the two pumps the next time, as I say. So what I'm going to do here now is I'm going to jump straight into these lines. I'm going to start attaching the fittings at this point of the check valve, and also running the luminous orange pipes. Then we will move on to the electrical to finish this off. All's good? Okay, so we have one piece of 6mm pipe on the pneumatic fitting attached to the brass tee. So I'm going to place this into position here now, sliding it under this pump, under the channel. So we have this pipe, which will be fed directly into the pressure switch. There we go. With the brass tee in position, I'm going to now run the pipe to this check valve on pump number 2. Okay, there we go. So I'm going to cut this when I'm at it just. Let's say, keep a wee bit of slack in it. Okay, so we're ready to attach this airline to this tee at this point. So you should be able to see it there, creeping out below this channel. So this now will be run to check valve number 1, pump number 1. So again, I'm going to keep a nice wee loop on this. I'm not going to keep it too short. So I'll say around there. So if I didn't mention already, this airline, this pneumatic pipe is nylon. It's not polyurethane. It's a wee bit more tougher than polyurethane for this job. So there we go. Okay, so we're going to finish off here by attaching the brass nut and this liner to the end of the pneumatic hose. So here we go. So placing the olive about 5 mil up the tube and then pushing in the liner here. So there we go. Perfect. Check valve number 2. Okay, so just before we move on to the electrical work here, I want to change out all these zinc coated bolts to stainless. So that's the bolts on the intake and the outlet here. So I have the bolts preloaded with washers. M8 on the outlet and M6 on the inlet. Okay, so that's this side of the head done. Have to do the same in the other pump, obviously. So I don't want, say, about a year down the line here, these bolts starting to rust. So that's the reason I'm changing them to stainless. So now on to this side of the pump. See if I get this camera set up here. Start with this middle one. So this manifold here's obviously something to do with the 2-stage pump. So basically it joins 2 ports together, and this is a cooler. Okay, so I'm going to move on to the other pump here and then we'll start the electrical work. But first I have to attach the black guards again. I will also use stainless steel for these. So 2 bolts at the top here and 2 bolts at the side. Okay, finally I am on to the electrical side of things. I have motor number 1 sitting on the platform. Motor number 2 is on the ground for the meantime because we need to get into this pressure switch before we start mounting the motor. Just makes things a little bit more easier. So, as I mentioned earlier, these motors are 4 kilowatt. So the maximum current in which one of these motor draws when operating at its rated voltage, frequency and horsepower output is 21.3 amps, seen here on this motor plate. So below the A there we see 21.3. A refers to amps. So we'll jump straight onto this control panel here. So this is the existing control panel, which was wired up to the old motors. So we have compressor 1, compressor 2, and basically when the lights is on, it means the motor 1's running and motor 2's running. Motor 2 is on a delay, and I will give a wee quick discussion on why that is. So here we have contactor 1, so that's for motor 1. Here we have contactor 2, that's for motor number 2. So the reason this contactor or this motor is on a delay is we don't want the 2 motors starting together. That would create like a very high increase spike in current. We can remove that by using this timer. So basically when one motor is running, we then start the other motor. So it's basically there just to keep the supply from a big surge of current be drawn from the mains, and in turn it would affect sensitive devices within the house or anything on that line, the income supply. Okay, so now that that's covered, I want to touch on the wires here and these thermal overloads and these cables. So the thermal overloads were previously set to around 16 amps on these markers, these little dial gauges. So that's very low, so that's obviously not going to be any use to me with these motors, because the rated current, the maximum current which these motors draw is 21.3. So I need to increase this value to say 26. So I need to be at roughly 25% higher than the rated current. So the wires currently run to these contactors are 2.5 mil squared. So that 2.5 mil squared wires or cables are rated at 25 amps. Even though they're rated at 25 amps, they can carry much more. It's tri-rated cable. So 25 amps is the safe working ampage, you could say. So that's more than enough for these motors. I wanted to go 4 mil just to go bigger, but I couldn't source the cable that I wanted, which was this yellow Arctic cable. So what I'm going to do here now is I'm going to remove these ones. So this is 2.5 mil squared. I don't want to use these again, and we will get into that now. And this one's just for a switch. So compressor 1, compressor 2, and a switch. I also need another gland now for the blow-off valve, because it was previously wired over to the wall here, which is no good. So next step now, we're going to focus on these cables. So this is the cable that I have selected for the motors. So it's 2.5 mil squared, capable of carrying, well, its rated current is 25 amps. So it's capable of carrying more. But I don't need to worry about that, because my motors are only pulling 21.3 under normal conditions. So the next thing I want to show here, well, there's 14 meters of that, and there's 14 meters of this. This is 1.5 mil squared. This is 2.5 mil squared. So the 1.5 mil squared is for the pressure switch and this blow-off valve. So I'm going to do that now, but I want to just touch on something else here. So rather than have the compressor wired directly to that control panel, what I'm going to do is use these sockets and these plugs. So we'll have 4 sockets hanging from the panel, approximately a meter off the wall, or sorry, a meter off the panel. So what do we see here? If I can get this set up. So we have 2 32 amp sockets, and inside here we have 3 pin. So that's for the 2 motors. Then we have the plugs. Then we have the 16 amp socket, and then we have a 16 amp plug. So again, we have this 16 amp yellow socket. So the reason I've got the yellow and the blue here and the 16 amp is because I want to keep the blow-off valve on the blue, as it's referring to 230 volts. The yellow will be the switch So the yellow will be just basically the switch that controls these contactors within the panel. That will be wired directly to these terminals. So I'm going to do that now. I'm going to jump straight onto it. Hopefully I haven't missed anything. As I say, these sockets will dangle approximately a meter down from the panel. And then we'll have 7 meters of cable running to the panel. Let's say if I ever wanted to take the compressor outside the door, which I doubt it, but I'm just going to do it anyway. So we'll do that now. Okay, so this is the wires for the drain valves on the wall, and also the blow off valve, the drain valve on the vessel. Okay, so the final thing needing done here is screwing these overloads up to 26 on the little dial. So there's 24, 25, 26, 24, 25, 26. Good job. Okay, so on to the sockets here now. Okay, so motor number 1, motor number 2, the switch, the pressure switch connection, and the blow off valve. So I'm going to adjust these in the panel here to have them at the same height. Okay, I had to call it quits at this part of the video. As can be seen throughout, the amount of work involved is huge, especially when you have over the top OCD. Therefore, a final section of this part 3 will be created to get this beast up and running. This video will also come lightning fast, just like this one, as all the recording was completed a few days ago. Stay with me on this one. In part 4, things get more interesting with 2 custom tensioners specially designed to tighten the SPZ belts with ease. If you want to see this project evolve, please subscribe and hit the post notifications bell to see all the latest from my channel. Also, if you have enjoyed this video, please give it the thumbs up. Other interesting projects will follow very soon, such as my one-of-a-kind green e-bike beast, my unique mechanical iris, my aperture, and my unique smart glove. Watch the space, it's only beginning to get more exciting. Again, see you all on the other side. Thank you and goodbye.